Hello, everybody. My name is Gregor Pipan, and together with my colleague Leon, we would like to welcome you at today's webinar. Let's just wait a couple of seconds more for everybody to join in, and then we'll go forward. Okay, I think we're all set now. Let me first share with you some technical information regarding this webinar. So the session is being recorded and it will be shared with you later on. We'll also welcome you to ask questions. For this purpose, you can find a section in the webinar dashboard and you can type your questions there. And we'll be happy to review them and send you answers either via email or call. There are many of you who don't know us yet, so let me first shortly present our company and our products. Our company, CGS Labs, has been active in the field of software development now for more than 30 years. One of our main fields of activity is the development of the software for traffic and infrastructure design. We are headquartered in Slovenia, and we also have 3 additional country offices in Germany, Czech Republic, and Serbia. And we also have a worldwide partner network. We're involved in the development of BIM and we're very active in the international organization Building Smart. And we also contribute to the development of standards in the field of digitalization of the infrastructure. About our software, with our CGS Labs civil solution, we cover 3 main civil engineering fields. This is road infrastructure design and maintenance, railway design and maintenance, and river and channel engineering works design. So in the road infrastructure design, we offer 3 products. One is Platea, which is BIM-ready solution for roadway design and reconstruction design. It is a complete solution. And then we have 2 smaller solutions. One is AutoSign, which is used for traffic sign and road markings design. It is a BIM software. And then we have also AutoPath software, which is analysis software for swept path analysis and vehicle turning simulation. In the railway design, we feature Ferrovia software, which is again a comprehensive BIM-ready railway design solution. And then, as mentioned, for channel and river engineering works design, we have Aquaterra BIM solution. And today, we will focus on software Ferrovia. We're going to talk about it. It is a BIM-ready software, which means that you can add all the data you need to the design 3D model of the railway, and then you can exchange this model using KFC data format with other software in your BIM workflow. It is a very intuitive software. It features intuitive user interface, which was designed based on the established design process. You can use the software for any kind of railway projects, no matter the type or the size of the project. At this point, I think it's best if we go into the technical presentation. And I would like to welcome my colleague, Leon Liban, who is Development and Product Manager at CGS Labs. I would like to mention that Leon has been part of Ferrovia since its very beginnings. He helped design the software. He's very knowledgeable about the software, and he knows really all the challenges that the engineer might face during the design process. So his knowledge is very in-depth. So Leon, please, you're welcome to share the presentation.
Yeah, thank you, Gregor, for the introduction. So hello everybody. Thumbs up if you can see my screen. Probably yes. Okay, thank you. So yes, as mentioned, as Gregor mentioned, my background is I do come from a civil engineering faculty in Ljubljana, and I was really interested in railways. Got into CGS Labs, and fortunately into Slovenia Railways as well. So let's say that we developed Ferrovia from bottom up, from ground up, with all the challenges that they faced, but then expanded to other European countries and worldwide, which is really great because we could then implement different parameters, different way of making things, different standards, geometries, which enriched, let's say, our knowledge in terms of railway design and its usage. So today's presentation is going to be not just theoretical, going through the sites. We'll have a hands-on. So I'll show you a couple of details. The portfolio that we have covers all the civil engineering, let's say, design, reconstruction works that need to be done with the software. So from Platea for roadway design, Aquaterra for river canals, then some other applications like AutoPath for the swept path analysis, AutoSign for traffic signs, road markings, Vedra roads. It's our IT solution for sensors on the road for winter service, and lastly Ferrovia, our railway design, reconstruction, railway realignment software, which handles it all, and we'll go through some of the details of Ferrovia today. First thing, and a very important one, is that all CGS applications run on top of CAD platforms, different CAD platforms, and we support Autodesk, Civil 3D, Autodesk, AutoCAD, or BricsCAD. So users can have any of those platforms, could have also later older versions of them, and they can still run the latest CGS Labs solutions. At this point, actually, we have a question for you. So we have prepared a poll. Of course, we are interested, let's say, what kind of CAD platforms are you using right now? So if you would like to share your information, which platform is in use in your company, that would be a great topic. Of course, all the three that are here and there are very similar. They differ as well, and they provide you different benefits. They have some downsides, but yes, that's an important part of using CGS Labs software solutions. Thank you. We are getting the votes in. Half of you already voted, which is good. So maybe no more. Yes, 60% good. So AutoCAD Civil 3D is the most used platform, as we can see. I think, Gregor, you can already share the results, right? So yeah, okay, 2/3 almost using AutoCAD Civil 3D. Many of them AutoCAD, which is interesting, and 15% of them BricsCAD. Just to notice that although BricsCAD and AutoCAD are, let's say, competitive products, we tend to provide the same functionality on both of them. Of course, there are some details which differ in terms of APIs which provide those CAD, but we can say that 99% of the features that we provide work on both platforms consistently. Okay, thanks for voting. We'll have another poll later on, so yeah, please keep your focus. We'll see what we have prepared also. Okay, important thing is also licensing. During the years, as you see, a lot of software solutions go on rental only or subscription. What do we use and offer are actually both. So permanent licenses are still available, which gives you first additional choice, and maybe some kind of security for, let's say, future use, if you have, let's say, that kind of requirements within your company. Another thing which is very important is that everything you do with CGS Labs software solutions, Ferrovia included, everything you design, it's DVG based. All the data is stored in the DVG, which actually makes it really flexible in terms of whatever you need to extract from those designs. So with Ferrovia, you can then export to different ASCII files like reports. You can put them in Excel or Word files, whatever, for the geometries, profiles, quantity takeoffs, etc. There are properties also stored in the DVG, so you can export them to IFC and the geometry to Landix and other formats. Some in Germany are used, also some others like Rep, Oxtra. So all of those formats can be supported. Within the Ferrovia, there's also a format supported by tamping machines from Plaza and Toyer, so the geo and ver files, which can be always exported when you do the, let's say, the realignment tasks within the Ferrovia. Another thing that's important is that those all the data can be stored in a single file, so you can design your layout, profile, cross sections, your BIM model in a single DVG. Or you can actually open new different DVGs and link them together by our project feature that we have. And you can then create a layout in one drawing, continue with the profile in another drawing, create cross-sections design and multiple cross-sections, let's say, design in different drawings. And then in a separate one, have the BIM model, which is very, let's say, data consuming. So that's a great feature to use. It also enables you to, let's say, to manage teams together, because some of them can already work on the cross sections, detailed cross sections. So this is a great feature to have. Also, all of our software solutions are localized, so we support now 9 languages, which are more or less country dependent. So if you look from our Austrian, Czech, German, English, Croatian, Hungarian, Polish, Slovenian, Serbian version, we also include in the standards, the standard value for, let's say, cant calculation, cross-section geometry, all those parameters are included. Although the English version is actually, let's say, an universal one, and we can, or you can, adjust those values according to the use in your country. So let's look at the English version as the most flexible one which you can use, but of course other markets demand, let's say, local language as well. So language is important, standards, guidelines, and content, as I already mentioned. So there are external XML files where, for example, the geometry of turnouts are stored, the parameters for cant calculations are saved. Then we have the geometry for the cross-section, geometry for the ballast track, etc. So there are more parameters which are, let's say, externally stored, and you can use them, customize them as well. Another great thing are labels and drawing styles, which are fully customizable. So all these labels are like external block files, dynamic blocks, where you can change the color, the line types, the font size, whatever you need, the orientation of those labels, and then thus you can have, let's say, your template for your use in your company for all the designs with it. Another thing which is important is also that Ferrovia comes in different software packages, so-called different license versions, from a standard to professional and ultimate. Standard provides you, let's say, all the geometry tools that you need, from layout to cross-section. The professional adds in the best fit analysis, so the regression analysis based on the existing rail tracks, turnouts and cross sections, and not the cross sections, the rail crossings, and then the ultimate brings you on all the additional interfaces for exporting data to BIM, let's say, LandXML files, IFC files, converters to civil 3D and vice versa, which we'll see later on, and much more. Okay, you can find a lot of Ferrovia resources on our web pages. So if you go to cgslabs.com, Ferrovia, you will see there is a free training web page with PDF files, videos, and DVGs in English version, where you can go through, let's say, some basic steps to get to the cross sections, and then continue based on, let's say, today's webinar to making BIM models, 3D models. If we look back, there were some great and amazing projects already done with Ferrovia, some greenfield projects. One of them was in Saudi Arabia many years ago. Lately, there was this Novi Sad Subotica, the Serbian new railway project connecting Belgrade and Budapest in Hungary, created with Ferrovia as well, designed by Ferrovia. And then we have daily many rail reconstructions and realignment works from many of our users from many countries, where, let's say, existing layout is surveyed, that survey data is analyzed, needed new rail, new alignments, new profiles are designed, new cross sections calculated, all the volumes are calculated based on the existing let's say existing material there and the new one that needs to be provided. As we see, many of our users use our turnouts and rail crossing commands for placing turnouts into those designs. And then from here on, let's say, we'll move to the 3D, to the BIM models. At this point, we have actually another poll, because we are, let's say, interested as well if you are already using some other software solution for railway design, and which is that. So apart Ferrovia. So you have here few choices. So you might be also in the group of other. So maybe just to get an overview what you're currently using, and that we can actually help you if you're using something else and you have issues there, so challenges, then maybe we can help you with Ferrovia as well. Okay, great, thank you. So the votes are coming in. So we have some existing users, as we see, which are already using Ferrovia. Many of you use Civil 3D for railway design, which is interesting, and few of you, let's say, are using other solutions, which we are also, let's say, interested in, but you can share that information after this webinar, where we will also be available. So I will use some data sets here, some IFC files, which will be available for you. Let's say, if you are interested, just contact us after the webinar, and we'll provide you the data sets which are used today. Okay, great, thanks. So half of you voted. So we have plenty of existing Ferrovia users interested in BIM. That's good. So how to move from a 2D design to detailed 3D and rich 3D design with information. And then we have some Autodesk users and some other software solutions which are in use probably locally in some countries. Thank you very much. So let's move on. So how can we get from CAD to BIM? The good news is that anybody using Ferrovia can continue with the designs they made in the past, and they can build them up to the BIM, to the building information models, and that's actually pretty easy. So already now you have the alignments, the profiles, the cross sections, which are done in 3D, and since you have them, it's pretty, as you will see actually today, it's pretty easy to turn that one into a 3D models. And what is good is actually that we can assign to those 3D models information. of properties. Let's say what kind of material it is, where it is placed, yeah, the volume of that material or that entity, to which alignment does it belong to, etc. And with this information, we are able actually now to create this so-called BIM models. Okay, so this one will go actually hands-on later on. What is important here to remember is that once you get to the cross sections and you do all that detailed design of your cross sections, either single track, double track, or multi tracks, which we can support. One of the important things is that you have to define, let's say, the materials, the quantities. So the material for your ballasted track, for your sub layers, let's say for the humus, the cut, the fill, and within our defined quantities, we have this list of materials where users can select an already existing list of materials with additional, let's say, a way of reproduction of them. So let's say you can say define the colors of them and some other properties, and you can also assign new materials. So there's this edit quantities. User can add in their own list of quantities, which are then assigned to the areas in cross sections, from cross section to cross section, and from that one, the calculation of material can be done and reported in a table in the drawing, but this makes the base for the 3D model design. And to create the 3D model, we have a special command, draw 3D model, which reads all the definitions of material that were defined, and user can then select from which, let's say, materials they would like to create a 3D model. They might be all of them used for the 3D model creation. And sometimes, in some cases, maybe just some of them can be defined. And what's interesting here from select quantities is beside the materials itself, those can be aligned with the geometry of the alignment, especially in the curve, and properties can be assigned. So there can be automatic properties assigned to those materials, and there are different property sets that can be used. As you can see here, so the base has a sub-ballast property set, the clearance has clearance property set, the crush zone has a ballast property set, because they differ in parameters that are going to be assigned. Okay, with that, we are actually, next step is the 3D model is created with all the details that have been done in those that have been created in cross sections. What's also important is that we can combine, so the 3D model can be combined from different cross sections, and you can actually draw the solid models here, let's say the noise barrier additionally to your existing 3D model in the drawing. All of these solids that are created have extended data assigned, so the property sets were assigned via the 3D command. And you can see here that, let's say, for example, this ballasted track is part of alignment 01. It has the granulation, so the granulation information, in what phase of the construction it will be used, and where is, let's say, its position, the station. And so you can query all those properties on all the objects that have been created. Another thing that's important here is once we have this 3D model, we can of course export it to IFC using our IFC export command. Of course, you can use, there are many IFC export commands in BricsCAD Civil 3D, which export data differently. So we would recommend to use ours. It gives you some possibilities here, and it's also good because all the colors, all the color coding, and some other parameters get exported as well. So here we have already BIM Vision. It's a free solution to open IFC files. And in this case, when we select an entity, we see there there are properties assigned to it, so we can query all the data from that IFC file directly. So one way is just to view them in viewers, but we can export this IFC file to other software solutions and get all that information from the properties from the IFC file directly. Another good thing is that actually here we created the track, the 3D model of the track, but we also created later on the clearance, the railway clearances, and we can add in this information by a second IFC file, and now we can see what space is required for this, for the rail passing through on our project, and then we can compare if we would have now here bridges or some side objects. We could also include, let's say, that information into it, and in some other solutions also query for crash collisions, etc. Okay, good. So this is our model that we have here. One of the important things is in our utility ribbon. So because all the ribbons that are in Ferrovia, let's say, follow your design process. So you start with the alignment ribbon, the profile ribbon, cross sections ribbon, and then you get to this utility and BIM ribbon. When you get to the draw 3D model command, which we saw before, property manager, where you can define, and we'll see it live, we can define different property sets. Then there's a property set editor when we can assign properties to the property sets or to the objects that are in the drawing. Then we have a property set filter just to filter out the objects that we need. Clash analysis can be done within the drawing already, or via exporting to IFC and then checking the clashes between other objects as well. There is an IFC exporter and important tool that we have, and there are some other also important converters. So civil 3D means that if I have a civil, and there is actually a third, 29% of Autodesk civil 3D users. Actually, with this command, you can convert your civil alignment to Ferrovia alignment directly. So on a click of a button, you get the Ferrovia alignment, and you can then go to profile, cross sections design, and 3D modeling directly in a couple of steps. So that's a very important one. And Land XML, which exports and imports alignment geometry, which you'll also see. And there are some other, let's say, other tools. One of, just to mention, our Google Maps import and export to Google Earth tools, where you can, in Google Maps, you can import the raster imagery, but also the elevation for your, say, wider area of your design. And you can export these 3D models to Google Earth as well. Okay. One of the nice things when you make those 3D models is, let's say, this kind of visualizations are actually easy to make with special software solutions that are dedicated for visualizations. You can achieve this kind of results based on your Ferrovia model in no time, actually. Here, we would switch to our CAD environment, just for a hands-on. So just to get a better overview how you can get to these BIM models and what the possibilities are there. And we will start from, let's say, an empty drawing where we only have surface. Surface just to, let's say, make easier the next steps. What we'll do here is we will import the alignment geometry. We have stored it in Land XML file. And what is important and interesting here is that once we read the data from an external file, we will also import in not just the geometry of the alignment, but we will import in, so we are going here to the alignment XML. So this is a Land XML file format. We will open it. And in here we have the two alignments actually. So the railway and the parallel alignment to that railway. And let's see, once we create, the program automatically redraws, let's say, the geometry from that file. So we have all the labels in. What is important, if we go now to our layout to our alignment manager, we are on railway 1, and we can check there. Not only the geometry was important, but also the existing, all the rail applied cant, which was defined for both alignments, has been also important, which is actually great, because by doing this, we can actually go to our profile, draw our profile directly. And once we have it, we have already all the horizontal elements data in it. We have all the applied cant information in it, and we can then simply draw just, let's say, our new profile. So this is all from an existing, let's say, project. This alignment could be saved from any software solution. So this is the way how to, let's say, move into Ferrovia. And once you're there, you go to cross sections, and you, of course, for making cross sections, we go to profile, and we go to layout, and we just need to add those cross sections on a different interval, depending on what we need. We add them. We go to our profile, we refresh the profile, because before I went there directly, which is also a possibility, and we get the 3D rails in our layout anyway. But now we have the cross sections in, and we can now simply draw our cross sections and go into it with all the details needed for the designing, as we saw it in the picture before. So here we have created, let's say, cross sections, and we have this main alignment in. In order to have the second alignment, we need to draw the profile for it, and then we can import the second alignment into these cross sections. In order to simplify that, I have already created this second profile with a superimposed profile. So I copied the profile data, profile elevations from my main alignment to my parallel alignment using the superimposed profile command. And then once we are here, we go to our main alignment. So this is our railway, because we would like to have in here the information. So we have to go into our cross sections, because we would like to have here this additional track. There might be more. So Ferrovia supports unlimited number of additional rail tracks, which can be added to our profile. And now, of course, we have the possibility to draw the geometry of, let's say, of our cross sections using commands for the ballasted track, the embankments, substructure, ditches, etc. One of the important features is that once you create that one and save that macro, you can reuse that macro at any time. So in this case, I have saved before my macro definition. So let me just open it in here, and I will go into details what this macro definition is. And yeah, I won't use now on the entire alignment. We can just, let's say, use a couple of them just to be much faster, quicker, and move on. So the idea of this macro definition is to store all the data, all the processes that you have created for defining detailed cross-section, right? So in here, this one, let me just switch off these areas. So we didn't put in just the geometry, which we defined it, okay? So one is the geometry of all the sublayers. We also added in the intersection points. So these are the string lines which are important to be recreated in your layout. But we also, if I look here, if I look into how this macro definition looks like, so actually here is a list of all the commands that have been used, let's say, while you're manually defining it, and you can still edit those things to a detail, and everything can be reproduced. So you see there's a lot of work that has been done to define everything within the, including the materials, right? So the cut, the film, and all those details. And this one makes it the base to your next step. So we've done now all the 2D analysis, design, detailed setup of everything. We simply go to a 3D now. We see that we can read the data from existing drawing. Okay, we will align those. These are the materials that we are interested in, and these are the property groups. So we can then assign to different materials, let's say different groups. So in this case, I'll define a couple of those. We don't need to define them now, all of them, but let's say a couple of them we create. We click OK, and then we are creating the 3D model. And in a moment or two, we'll be able to see the results. What is interesting within these models, so let's go here. So we see that now on the beginning of our alignment, let me just switch this view. We don't need this one now, so let's remove it just to make it clear and switch to a 3D or realistic mode. And you can see here that we have here all the cut or the fill materials and our ballasted track and also our rails. And if we look at our ballasted track, so if we look at the properties, extend the data, so this ballasted track is part of our alignment, one. It has the attributes for its, let's say, the material definition, what kind of material has been used, in which phase it was used. These were all presets in our property sets, as I mentioned before. So we have here on our utility the property manager, where we have, let's say, these property groups. We can create at any time new groups, and we can always use a template for, a previous template to create a new one, which can be then just edited. Some of the properties can be added, some can be deleted. And once you create them, you define, these are the first 6 here are always automatically applied. So the information to which alignment, the material which derives from the cross sections, the code which can be assigned, the stationing, and the volume. And then user can define, let's say, my property, and that properties can be anything from a text to values, and they can be applied to the, let's say, to this material. The property set here tool enables us to select. We have the sub ballast. We have the sub ballast values. Of course, they vary because we have different things. But the thing is now that we can, to this one, we can then assign also another property, property group. So we can have more of them, and we can go here and define, let's say, in here, let's say our own. I think it would be better to put in the new one as I created. So we could assign here our new value to it. Okay, this is a very nice feature. What is interesting here is, let's go to some of the. So I have created here more complex BIM models just to see to what level of details we can come with creating of the 3D models. So this is now actually the same part of rail track that I was working on, just that it was, let's say, that we've used a little bit more time on it, on all those details, switch to a realistic. We've also added the clearance envelope as well, which is again defined as a material within the borders of that envelope profile in cross section, and then the profile 3D model is created based on the information along the profiles. The only thing that here in this model are additional are these 3D objects, which have been put to the position defined by let's say by Ferrovia, but they were added in as a 3D object additionally. Okay, and as we can see here, we can go to any entity here and see that on this one, that these ones, okay, the ballasted track has the properties, and some of them, let's say these ones have, but there might be some of them, maybe I just clicked wrongly, sorry. So they have all the information here. Again, when you create a really detailed model, like in this example, select similar with the use of, let's say, property set editor, you can see here that we have, I just need to select these ones with the property set editor. We see that there is only one group of properties, and we can now say, look, I would like to add another group to it. Let's say the one that I created before, the new, that one is assigned, and now I can go there and define my property. So this is a clearance UIC defined by your let's say your specific guidelines, and that one is then assigned. You can export it to a C file, and you can then view that file anywhere else. One more thing in terms of BIM, which is also very important, because the BIM models tend to be really data consuming, and let's say the performance of the CAD drawings can decrease, right? So when you create in any software solution, when you create those solid models, you have a lot of entities and a lot of data, and these files become very, very big. So the thing we have here is, if you look, what is the difference between this this example, if I have it here, let me just show it. This was an example where we have created all of our design within the same drawing, as I showed you before, right? So the alignment design, profile, cross sections, and then the 3D models with the additional information. One interesting thing that Ferrovia offers is that you can open an empty drawing and then click on draw 3D model command, and I've already assigned to read the data for this model from a DVG, so it will just take me a moment or two. Now you see I have the data source, and my data source is my external file. This is a Ferrovia 24 BIM demo, okay? And we are now working in an empty BIM file, okay? So this is our source. We can select, because we have different alignments there, we can have different models there to assign to different alignments, of course. And what we need to do here is, let's say we will create additional part of the BIM model here. So we already have a part here, and we can then choose what to do with those entities. So if we align them, so wherever we have a curvature, we can then have those solids curved as well. We can assign the property groups to each of the material we have. And then when we click OK, so the software goes through all those definitions of materials and will add the BIM model to the drawing. So you see here we are now, let's say, creating all those objects additionally to the ones that we already have. And with this, we have a true representation of our BIM model based on the 2D drawings that we have elsewhere, which is also a great possibility to maybe store the states of that models as they were before, because once you change them, you can always recreate the models and then see the differences as well, but also to have all those models in a different or separate drawing. Okay, good. I think you got the idea here. What can be done with the Ferrovia, with your current Ferrovia, with your current 2D drawings, to go to 3D and BIM within a couple of commands, actually. Just few things which needs to be important. Google Maps was already mentioned, so we won't stop here a lot. What is important is the digital terrain models. We support native civil surface, so you can have a civil surface and we can project Ferrovia alignments to those surfaces directly. The same with BricsCAD. If you have BricsCAD and surface created with the BricsCAD commands, we support it, we project directly, we don't convert it. But Ferrovia also provides its own digital terrain modeling tool, which also works on AutoCAD. So all the AutoCAD users that were there were a third of you almost, you can use our Ferrovia surface creation tool. As well, we can project on 3D faces directly. So if you, let's say, have a civil 3D surface, double explode it to the 3D faces, you can then open that one in our plain AutoCAD, and Ferrovia will project that surface. And you will be able to go to profile cross sections, create 3D model as well. So that's a good one. Grading is another way of creating the embankments, which are, let's say, even more accurate than profile to profile, depending on the situation what you need. Ferrovia Ultimate also provides you the site design tools, which are a great addition, because you can, let's say, in this way, you can, with the polyline editor, you can select any polyline, you can project it to a surface, you can create from a 2D, 3D polyline, you can then change the elevation, the grades, the slopes, whatever. We can then create 2D or 3D polylines from a string of points or survey points that you have. So you can recreate, let's say, your 3D alignment from your survey points. We have done polyline section, because when you have a long polyline, maybe 10 kilometers, you might be interested, maybe just in kilometers. So we create a copy of that polyline just in that section, the polyline offset commands, and labeling any polyline. So any polyline you have, you can add labels to the vertices and to the sections, which is also a great addition. We are not spending today much about the geometry and the regression analysis tools. Once you have your existing rail track survey, you can recreate an alignment by using our best fit function. We have other tools to create alignments as well. So the draw tangent polygon, but also the floating, the fixed elements. We can create parallel alignments directly, convert polylines to tangent polygon, convert polyline to specific small elements, and also convert floating elements to this tangent polygon to floating elements directly. What is also important that within Ferrovia, many spiral types are supported. So from clotoid, some cubic parabolas, number of cubic parabolas, mostly in use in this Eastern European region, but also non-linear parabolas. Within them also the Japanese sine half wavelength spiral, which was a requirement from our customer. Okay, the turnouts are already in. There's a preset library of turnouts in Ferrovia, but you can also, there's a library feature when you can add your own geometry to the library, to the file that you have, and you can share it with the colleagues. There's a rail connection tool between alignments, and we are coming back to where we already were. So the macro functionality is a really great tool to speed up your process, because once you create the cross-section definition that you are supposed to use, you can recreate it just by running that macro, and you can have then a list of different, let's say, stages of that cross-section definition in that library of macros. Not just geometry, also the materials can be stored in those macros and recreated. Multiple tracks can be created, and the quantity takeoff. There are actually, as you saw today, there are two ways. One is the traditional way, when you calculate that, get into this table, which can be also opened in Excel, or you can store all the volumes into the model, into the IFC, and then get the dead values of the volumes from the quantities from the material directly from the IFC files. Okay, not just solids as we saw today. As I showed you before, the string lines that there are, we can create surfaces as well. Surfaces for, let's say, your base layers, your top layer for the ballasted track, or whatever surface you need, maybe for the embankments. That's also a possibility. And here in this picture, you can see that all these embankments were created by surfaces, and you can export that data to IFC, but also LandXML and other file formats as well. This one was already covered today. What's important is that currently we have the IFC 4.2 file format that we support. We are working on 4.3, where also export of alignments, profiles, and cant data will be possible to export it in IFC file format and import it from it. So today what I've showed you was using LandXML, but we are working on this 4.3 file format as other software vendors as well. What is important here is, as we saw, it's also that all the properties, all the information can be assigned, and what's even more is that actually then you can combine, as in this example, the bridge was created by a third-party application. From an engineering point of view, it was saved on an IFC, and we have just imported it into our DVG so that the roads connecting this, let's say, going to this bridge and passing it, we could define all the embankments, all the entities that are part of that open road accordingly. Also, not to forget, is within Ferrovia Ultimate license, you get all the Platea road design tools. So you might use them for the possible access roads, for any, let's say, light rail designs where you have to combine roads and railways within an urban areas, or you can do some road design as well within the Ferrovia Ultimate licensing. So you can, in the end, you can create a very complex civil projects as well. Yeah, that's not all. Actually, we have more. As in the second slide today, you saw that we have some additional software solutions, and I'll just name two of them. One is AutoPath. It's our swept path analysis, which, of course, with all the national vehicles for which you can do the swept analysis, we also support the, let's say, the exceptional vehicles, let's say, or the heavy haul vehicles to transport, let's say, some of the construction materials to your construction site, and you might need to do the analysis whether a semi-trailer with this exceptional load will be able to reach your construction site. And another thing is the AutoSign, where we have already a list of traffic signs libraries, but you can also create your signals as a 2D blocks, and they can be created as 3D signals within the AutoSign solution. You can get more resources for AutoSign on our web pages, on webinars for AutoSign, same for AutoPath. And with this, I would actually like to thank you all and pass the word to Gregor to finish it off. Thank you.
Thank you, Leon. Just give me a second. Okay. Yeah, thank you for this very in-depth presentation. I have just a couple. Okay, we jumped somewhere. Just a second. A couple of more slides. So if anybody is maybe interested in trying the software that you have just seen, we offer a free 13-day trial for every software that we develop. Our trials are not limited in functionality, so you can really test in depth and see how the project can get done with Ferrovia. To support that, we offer also a free basic training, which you can access through our web pages. We have a section CGS Labs Academy, and actually there you can find free basic trainings also for Platea and Aquaterra for all our major products. Then what is important is that we offer a live technical support to our customers. This is also for our trial customers. So if you're going to test our software, you can consult our engineers. Live support is very important, we think, because sometimes you cannot work things out only with online knowledge base, which we do feature anyway. So we also have the 24/7 accessible knowledge base, which contains all the user manuals, installation instructions, and so on. One of our most valuable resources is also our webinar library. There you can find several webinars specialized for civil engineers for various products. Maybe you should take a look. All these resources are accessible directly from our webpage. And maybe to mention some more of those, Leon, I think, mentioned already, we feature a blog, which is a combined blog for all our software solutions. We have a really large YouTube channel where you can find all sorts of videos, from get started videos to a bit more extensive webinars. I already mentioned the Go to Stage channel, and we also are active through LinkedIn networks, so we publish all our knowledge also through LinkedIn. So I invite you to find us and follow us for the future. I would like to thank you for your attendance at this point. This concludes today's webinar. We hope it was useful, informative, and that you enjoyed our company. And I hope that we will meet again soon in one of our next webinars. For all of you who posted questions through the dashboard, we will aggregate them and prepare answers and send them to you via email. Thank you for today, and goodbye to all.
Thank you and bye.